So now that we've looked at differentiating implicit functions, we want to be able to look at finding the second derivative of an implicit function, because higher order derivatives can also be found implicitly. So in our example, we want to find the first derivative and the second derivative in terms of x and y for the function y of x defined implicitly by x squared plus 4xy equals 4. So the first thing we're going to do is we're going to find that first derivative, and we need to have a look at this 4xy term because we need to use the product rule in order to differentiate that. So u is going to equal 4x, v is going to equal y, so u prime is going to equal 4, and v prime is going to equal 1 times dy by dx using the chain rule. And so u prime v plus v prime u is going to give us 4y plus 4x dy by dx. So now we're going to substitute that in to our implicit function as we differentiate both sides with respect to x. So the x squared is going to differentiate to 2x. Then we're going to have this 4y plus 4x dy by dx. And that's going to equal 0 because 4 differentiates to nothing. So now we want to take away that 2x and that 4y from both sides. So we're going to be left with 4x dy by dx equals, and I'm going to put it into a bracket, negative 2x plus 4y. Now the next step, we want to isolate that dy by dx, so we're going to divide both sides by 4x. And while I do that, I'm also going to take out that common factor of 2 to get negative 2 upon x plus 2y all over 4x. Now I can do some simplifying. I can cancel out that 2 on the numerator, and that will give me 2x on the denominator. And so my first derivative for this implicit function is going to be dy by dx equals negative x plus 2y all over 2x. Now in order to find the second derivative, I'm going to use the quotient rule. So bringing my first derivative from the previous slide, I had dy by dx equals negative x plus 2y all over 2x. So to use the quotient rule, I need to identify u, and I'm going to let u be x plus 2y, and I'm going to take the negative with my v and make v negative 2x. So u prime is going to be 1 plus 2 dy by dx, because x differentiates to 1, and the 2y differentiates to 2 dy by dx using the chain rule, and v prime is going to give me negative 2. So my second derivative, d2y by dx squared, is u prime v minus v prime u all over v squared. So u prime is 1 plus 2 dy by dx, and I'm going to put that in a bracket because I need to multiply that by negative 2x. And then I'm going to take away v prime, which is negative 2, and I'm going to multiply that by x plus 2y, again putting it in a bracket. And all of that is going to be over my v squared, which is negative 2x all squared. Now, I want to get rid of that dy by dx, and I can do that by replacing it with my first derivative, the negative x plus 2y all over 2x. So my next line of working out is going to give me d2y by dx squared equals, and I'm going to multiply out that bracket, so I'm going to have negative 2x multiplied by 1, so that's going to give me negative 2x, I'm going to have a positive 2 multiplied by negative 2x, which is going to give me a negative 4x. And then I'm going to have my negative x plus 2y all over 2x in a bracket to replace that dy by dx. So I'm going to highlight that again to show where that's coming from. And then I'm taking away negative 2 and I'm going to multiply out that bracket. So I'm going to have positive 2 multiplied by x is going to give me a plus 2x. And positive 2 times positive 2y is going to give me a positive 4y. And that's all going to be over negative 2x squared, which is going to give me a positive 4x squared. So now I want to do some tidying up. So d2y over dx squared is going to give me negative 2x. Now I want to simplify that fraction. So I've got a negative 4x on the outside of my bracket, and if I take that negative with the denominator like I did when I was isolating u and v back at the beginning of the quotient rule, I can cancel that down. So I've got a negative 4x, that's going to become a positive, my denominator is going to become 1, and I'm going to end up with a positive 2 on the outside of my bracket. So when I'm expanding that bracket, I'm going to get positive 2 multiplied by x is going to give me a plus 2x, and the positive 2 multiplied by positive 2y is going to give me a plus 4y. And then I'm still going to have my plus 2x and plus 4y from my numerator all over 4x squared on the denominator. Now, the first negative 2x and positive 2x are going to cancel each other out because that just equals 0. And then you can see that I'm going to have d2y by dx squared is going to be 4y plus 4y gives me 8y plus 2x, and that's all over 4x squared. Now I want to take out a common factor. So from the previous slide I had d2y by dx squared equaled 8y plus 2x all over 4x squared. So I want to take out a common factor of 2 on the numerator. So I'm going to have d2y over dx squared equals 2 upon 4y plus x all over 4x squared. And my final step will be to cancel down that fraction to simplify it. So the 2 will cancel out on the numerator to become a 1, and the 4 will become a 2. And so my final answer for the second derivative of this implicit function is 4y plus x all over 2x squared.